All right, so we know how to find how much off the volume is or the surface area is with differentials. Relative error will kind of give me the answer to the question, does the error matter? So the error of dV over the V gives me a relationship between the two, so I can make a decision whether the error matters or not. So let's see, I want relative error in volume of a sphere. Okay, so that means I am finding dV over V, and I'm going to encourage you not to go do the computation, but actually write out the algebra. So volume is 4/3 pi r cubed, and then the dV for the volume, right? So 4/3 pi carries along, and I have 3r squared dr. Now, the reason I'm encouraging you to do this is there is a lot of cancellation. So I'm going to have so much less computation as a result of doing it this way. So I see the 4/3, the pi's cancel. In the numerator, I'm left with a 3 and a dr. In the denominator, I just have an r. So now I can plug in what I have the surface, the radius is measured as 2. And how much the radius is mismeasured is 0.005. So I can find that dV over V is equal to 3 times 0.005 divided by 2. So that gives me 0.0075. All right. So that gives me an idea of how much the volume it is relative to what the volume is. So one more indicator is to find the percentage error. So it's taking this same thing, this dV over V, and writing it as a percent. So for this particular problem here, the percentage error would be 0.75%. So that gives you a real indication of does the error matter. All right, let's do another one here. So now I'm going to find the volume of a cube, and I've got the side length measured as 4, and then the mismeasurement is 0.03. So again, I'm going to encourage you to, since we're finding the volume of a cube, so it's dV over V. So volume of the cube is x cubed. The dV will be 3x squared dx. So simplifying, now I can go plug in just a couple of things in here. So I have 3 times 0.03 divided by 4 gives me 0.0225. So writing this as a percent, I get 2.25%. All right, one more. So I've got here a cube again, measured with the side length of 10, and I want to find the error in finding the surface area. So it doesn't always have to be volume; it could be surface area. So let's set it up. So ds over s. So surface area of a cube is 6 sides of area x squared. To find ds, that would be 12x dx. So I know I'm going to be using x is equal to 10 and dx is equal to 0.01. So let's do some canceling here. So I get a 2 dx over an x. So my ds over s turns into 0.01 divided by 10. So that gives me 0.002. Changing that to a percent gives me 0.2% error.